All right, next we're going to start talking about elimination. So, for example, I want to first look at a problem because we haven't really done elimination in class yet. We're doing it on Tuesday. So let's see here. An example of an elimination. So when you have two equations like 2x minus 9y equals negative 59 and 6x minus 9y equals negative 87. We can see that we don't have any variables solved or quickly solvable for to be by itself for substitution, right? This problem is not set up well for substitution. And it's really not set up that easily for graphing. I know Desmos makes graphing a lot faster and easier, but back in my day, we didn't have Desmos. And sometimes, you want to be able to just see y equals mx plus b form for that kind of thing. So you can quickly see what's the slope, what's the y-intercept, and kind of go from there. So standard form, when you have your two equations written in standard form, you want to use the method of solving called elimination. And what elimination is doing is saying, hey, I have this equation, this 2x minus 9y equals negative 59, right? And I can do my properties of solving say that I can add or subtract anything I want to the equation as long as I do it to both sides of the equal sign, right? So if I wanted to subtract 87, I could do that. I just have to keep my equation balanced and do it to both sides of my equal sign, right? So I would have 2x minus 9y minus 87 equals, whatever 59 minus 87 is. Let me see. Negative 59 minus 87 gives me negative 146. Okay, so we could do that, although that still didn't really help us much, right? Because whenever we're solving, right, and we have two variables, we know that, you have two things that are unknown, and we need to somehow get to, an equation where we only have one variable or one thing that we don't know so that we can figure out that one thing. So, since we know, hey, I can add the same thing to both sides of my equal sign, and I know that negative 87 right here is equivalent to this 6x minus 9y, right? Those are the same thing. So I could approach this problem equals negative 59 by subtracting 87 from the 59 or adding a negative 87 and also adding the 6x minus 9y, right? This is the same thing as 87 because of this equal sign. I know that that's true. So I'm still technically keeping my equation balanced. Okay, so I can add or subtract anything I want to both sides of the equal sign as long as they're equivalent and I keep my equation balanced. Well, so now we want to think, how can I use this strategically, right? Because I want to get rid of or eliminate one of my variables. Well, so here I see this minus 9y in my first equation and this minus 9y in my second equation. So if I subtracted, right, if I took negative 9y minus a negative 9y, I would get 0y, because when I have a negative minus a negative, I'm actually doing negative 9y plus 9y, right? So I would get a 0y. So that's what I'm going to do my method of elimination here. Okay, I'm going to do the opposite to get those 9y's to eliminate, right? So in this case, I'm going to subtract my entire expression down. Now, the nice thing is when you have your equations written in standard form, they're already set up to combine like terms, right? So you just subtract down. 2x minus 6x gives me negative 4x. Negative 9y minus negative 9y leaves me with 0y. And negative 59 minus a negative 87. Now let's see here. When you do minus a negative, so negative 59 minus negative 87, right? You're really doing a plus, so you get 28, okay? And I know, hey, when I multiply 0 times y, I just get 0. Negative 4x plus 0, right? Negative 4x plus 0 just stays negative 4x. Well, hey, that worked out pretty nicely because now I have an equation with just one variable, and I know how to solve that for x. So how do we get rid of that negative 4? It's being multiplied by our x, so the opposite of multiplying is dividing. If I do it to one side of my equal sign, I do it to both sides of my equal sign. So I have x equals, let's see here, 28 divided by negative 4 leaves me with negative 7. All right, but just like with substitution, at this point, I know I'm not done yet because I need to find what y is. So I can go back up and pick either of my two equations. So I'm just going to use the first one, 2x minus 9y equals negative 59. And I'm going to plug or substitute that negative 7 in for my x. So 2 times negative 7 minus 9y equals negative 59. And now I'm going to simplify and solve to find what y is. So 2 times negative 7 is negative 14. Minus 9y equals negative 59. I'm going to add 14 to both sides of my equation. Whoops, that's a 14. Sorry, it's a little sloppy. So I end up with negative 9y equals, I'm going to do negative, let's see here, negative 59 plus 14 gives me negative 45. And I'm going to divide both sides of my equal sign by negative 9 to get rid of that. It's out in front of my y. So I have y equals, and let's see here, negative 45 divided by negative 9 leaves me with positive 5. So my final answer here to this solution or this system of equations would be negative 7, 5. And that's how you solve by elimination. You just add or subtract your equations. All right, so let's see here. So if we hop back over to Delta Math and we look at this first one that you're being asked to do, this elimination strategy, all they're asking you here is to tell what is the first step in solving the system by substitution. So it's really walking you through elimination, step by step, right? So all you're really looking for is which of my variables am I going to be able to eliminate by either adding or subtracting the equations, right? Well, so hopefully you see, hey, I've got a 4x here and a negative 4x here. So what do I need to do to make 4 and negative 4 go to 0? Well, for those, we would just add. So we can add the equations to eliminate the x variable. And voila, okay? Same thing here, right? If we do another one, now I see I have a negative 1x and a negative 5x. Well, those aren't the same. Let's check my y's. I have a negative 6 and a positive 6. How can I make those become 0? That would be how I would eliminate it, right? So I would add negative 6 plus 6 to make 0y. So I'm going to add to eliminate the y's. Voila. And then they show you down below, right? You would add it, and you would end up with negative 6x equals 48. And that's that first elimination strategy.